Hello students, now let us try to understand the isochoric process student, isochoric process. So when you talk about the isochoric process students, that is isochoric means choric means volume. So that is volume is constant student. So let us read out and try to understand in detail student. A process in which volume of the system remains constant. A process in which volume of the system remain constant throughout the studies is known as isochoric process. So volume of the system is remains constant. That is isochoric process. For an isochoric process, delta V is equal to 0. Isochoric process, that is volume change is 0. What is isochoric process? Quasi-static process. Okay, isochoric process means quasi-static process. So they are saying the isochoric process is process that takes place at the constant volume V constant, that is delta V is equal to 0. In the PV plane, an isochoric process is represented by a straight line parallel to P axis shown in figures. Okay. So here next one, what happened in isochoric process? What happened in an isochoric process is one in which the volume is held constant, meaning that the work done by the system will be 0. Okay. Isochoric process is one in which volume is held constant, meaning that work done by the system will constant. It follows that for the simple system of two dimensions, any heat energy transferred to the system extremely will be absorbed as an internal energy, right? Next one, here see student, for isochoric process you are getting a straight line to parallel to the P axis. This is PV diagram is there, P is constant at the fixed place, so that is isochoric process. Here also the same diagram, if delta V is equal to 0, delta V is equal to 0, it means work done is also 0 student. Okay, now PV diagram, heating you are heating at constant volume, so here what is happening, that is W equal to 0. Now student, isobaric process, here you see that is this is the parallel to volume axis, the graph is a straight line. Okay, and isochoric process, that is a straight line parallel to the P axis, and isothermal process, that is it's a very slow process. Isothermal process, you can see very slow process, the graph is changing, and adiabatic process, it's a very fast process, you can see the graph. Okay, next one, a graphical representation of various thermodynamic process is straight line isobaric process, this straight line isochoric process, this line isothermal process, this line adiabatic process. Okay, if dq is equal to 0, process is adiabatic. If dt is equal to 0, process is isothermal. Is dp is equal to 0, isobaric isochoric, dp 0, isobaric process. Okay, so in adiabatic process, q is equal to 0, isothermal t is equal to 0, isobaric p is equal to 0, isochoric b is equal to 0, and if it is cyclic process is there, so delta is 0, delta h 0, delta p 0, delta v 0, and delta 0 t 0, everything is 0. So this is all about the isochoric process. Thank you so much for watching, friends.